Assalamualaikum and good morning to the lecturer. We are from section 3 group 4 and we are doing the experiment 5 which is Pelton turbine for lab BMM 3521 fluid mechanics lab. First of all, I would like to introduce myself. My name is Muhammad Altaf Najwan Birusdin, ID metric MA19148, and I'm going to introduce my other teammates, which is Muhammad Aiman Shakir bin Abdullah, MA18266, Muhammad Hazim bin Muhammad Razali, MA18280, Irashana anak perempuan T. Ramachandran, MA19005, Wan Muhammad Ahmad bin Wan Muhammad Hafiz, MA19019, and the last one, David Frickson anak Akiat, MA19154.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Ammar bin Wan Muhammad Hafiz. My ID metric is MA19019. I want to explain about abstract. This experiment 5 is on Pelton wheel turbine using a various flow rate of water toward Pelton wheel turbine. Water then rotate the Pelton wheel using a different flow rate, so we'll achieve the highest efficiency of power output. We need to identify the rotational speed in 1 per minute, movement on the shaft, our output, and the efficiency by using calculation based on collected data. Depending on the wheel efficiency, the power delivered can be calculated from the speed and the cross-sectional area of the jet. From the collected data, power curve can be plotted based on the movement of the shaft, rotational speed, and power output. To proceed the experiment, apparatus like Pelton wheel turbine, hydraulic bench, and tachometer must be prepared. In the end of the experiment, the collected data can be elaborated in detail in a discussion on the efficiency of the Pelton wheel turbine. That's all for me, thank you.
The introduction of the Pelton turbine. A Pelton turbine or Pelton wheel is a type of impulse turbine used frequently in hydroelectric plants. This type water turbine invented by American inventor Lester Allen Pelton in 1870s. These turbines are generally used for sites with high heights. The water in a Pelton turbine is moving quickly and the turbine extracts energy from the water by slowing the water down, which makes this an impulse turbine. When used for generating electricity, there is usually a water reservoir located at some height above the Pelton turbine. The water then flows through the penstock to the specialized nozzles that introduce pressurized water to the turbine. To prevent irregularities in a pressure, the penstock is fitted with a such tank that absorbs sudden fluctuation in water that could alter the pressure. The water turbine is known as an impulse turbine. This simply means that instead of moving as a result of a reaction force, water creates some impulse on the turbine to get it to move. The problem statement of the experiment of Pelton turbine. The Pelton turbine is an impulse turbine with tangential flow. It is used when there are high of pressure and low of flow. It has a large wheel or runner that has bucket turbine blades that absorb the energy in the water. The buckets are impressed to correctly balance the wheel and to work efficiently. The objective of Pelton turbine is firstly to determine the relationship between flow rate or speed of Pelton wheel and power. Second, to determine the characteristics of Pelton turbine. And third, to determine the power curve. The scope of this study is to determine the relationships of flow rates and the power generated. Instead of that, is to study the efficiency of the Pelton turbine. Other than that, determine the relationship of torque and speed of Pelton turbine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Shakir bin Abdullah. My metric is MA18266. So I will continue with theory of the Pelton turbine experiment. So the Pelton wheel is a turbine to convert fluid energy to mechanical energy. The pressure due to a head of water in a reservoir above the turbine is converted into kinetic energy in the form of a jet, which then impinges on a series of targets mounted on a wheel, transferring energy from the water into rotating of the wheel. So this is just like the example of the use of the Pelton turbine. So as you can see at point 1, we can apply the Bernoulli equation, and this is how it looks like at point 1, where ZR is the elevation from the water level, the V is the velocity, and P is the pressure. And this is how it looks like if we apply the Bernoulli equation at point 2. So using the principle of conservation of energy, we get E1 plus HA equals to E2 minus HR plus HL. And HA is the energy added by the pump, whereas the HR is the energy removed. Therefore, this is the general or the overall equation that we get if we use by looking at this example, this scenario. So at the surface of the reservoir 1, the fluid moves very slowly compared to the pipe, so we can say it is equal to 0. Also, the pressure is atmospheric pressure. Zn minus Zr is the evaluation from the nozzle to the water level in the reservoir, neglecting the minor and fractional losses. So the result for me.
Hi, my name is David Fritson Anaket, MA19154. So now I will proceed to present on the apparatus and procedures in this experiment. So here you can see the setup of the Pelton turbine experiment, which specifically shows the above part, which is the Pelton turbine. This Pelton turbine consists of spring balance, manometer, nozzle adjustment or spear adjustment, Pelton wheel, and brake adjustment. So this is the typical setup of an turbine experiment. So next, here we can see the setup or the next part, which is the bottom part of the apparatus, which is known as hydraulic bench. Hydraulic bench consists of flow control valve, overflow, storage tank with pump, valve, measuring tank level, and measuring tank. So next, we proceed to the procedures. Before we start or run the experiment, we need to make sure that the connection of the pipes are tightly connected and no leakage. The emergency button is released. The emergency button, you can find it or located on the front side of the hydraulic bench. Next, during the experiments, you must make sure that the water is in full tank or add the water in the hydraulic bench to full tank to supply water during the experiment. Next, the hydraulic bench is turned on and the valve is in vertical orientation. The spear controller is released to control or fix the volume, flow rate, and also the flow velocity. Next, switch on the main switch and the measuring tank level are measured after 60 seconds and the data are recorded. Finally, observe the flow sensor, the pressure sensor and tachometer and record the data collected or measured. After we finish doing the experiment, make sure the valve is turned to horizontal, which means enclosed, and the main switch is switched off. after the experiment is done. That's all from me. Thank you.
Good day and hello to the lecturer. I'm going to present about result and discussion for Pelton wheel experiment. So the first part is the result for turbine characteristic curve, and the details given, it is fully open and the constant pressure is at 0.2 bar and constant flow rate at 30.9 liter per minute. So this is the table for turbine characteristic curve, and as per given, moment on the shaft is given in mega Newton. So I change it to Newton so it can be clearly seen the flow of the data is increases as the rotational speed decreases. And here we have power output, which is in increases form, and the constant power input is applied with Newton 10 watt, and the efficiency also increases as the power output increases. So from the turbine curve, we generate three graphs, which is torque versus RPM, power out versus RPM, and efficiency versus RPM. So based on these three graphs, the flow of the graph is inversely proportional, which is as the torque decreases, the rotational RPM decreases, the torque also increases. So basically this graph is inversely proportional. And the next one is power curve, which is given details is pressure at 0.2 bar and Q, the flow rate is 18.75 liter per minute, and which is lesser than the turbine characteristic curve. And the data given here as follows: the RPM is in decreases form, and the power output is increases until 415 RPM, and it decreases afterwards, which is until 350 RPM until 130 RPM. So this is the result part for the Pelton wheel experiment, and from that data we generated a graph. So the graph where power out versus RPM to show the graph of the power curve, and the peak here shows the value of the highest power out versus RPM. So the next one is the discussion. So for the discussion, based on the torque versus RPM, it clearly shows that the torque is actually known as moment of the shaft, and it is increases as the rotational pulse speed decreases. So actually this happen is due to we have constant power input that causing the torque and the speed to be inversely proportional. So what we can conclude is the torque, when the torque is high, the speed tends to be low. So whenever we have load is applied directly to the wheel of Pelton, the load applied increases, friction and the torque increases, then only the speed decreases. So based on the power output versus RPM graph, it shows the graph is inversely proportional. When the load is applied to the wheel, there is friction between belt and wheel, and this creates torque and causing the output power to be produced. So as per the graph, the output power increases as the speed decreases. So based on the efficiency versus RPM graph, it shows the efficiency increases as the power output increases with the speed decreases. Based on the power curve graph, shows the RPM decreases from 760 RPM to 450 RPM, while the power out is increases. After the 450 RPM, the value of the power output decreases with the decrease of speed of the rotation. So based on the result from this experiment, what we can conclude, speed is the best performance at 601 RPM because it gives the highest value of output power, which is 5 watt, with higher value of efficiency, which is 50%. So this shows that the at 601 RPM it is the highest value of output power. Moreover, the maximum power generated by the Pelton wheel is at 415 RPM with 3.1 watt based on the power curve, while based on the turbine curve, the maximum power generated at 601 RPM at 5 volt. So the maximum torque produces is 0.075 meganewton, or it's 75,000 Newton at 601 RPM of speed. So this is based on the turbine speed, turbine characteristic curve, and the efficiency of turbine is highest at 5 watt power output, which is 50%. This is show that the efficiency is directly proportional to the power output. So the nozzle is actually affect the performance of the Pelton wheel. So nozzle playing an important part in the Pelton wheel experiment. So this is because when the water size come out from the nozzle is small, the water flow in high velocity and hit the blade of the wheel. So this is because pressure is force per area. So the overall view of the result is that the decrease the RPM, the increase the power of the output, the increase the power of the output, the higher the efficiency of the turbine. Moreover, higher the torque, the highest the efficiency and the power of output. So this is the discussion and result part for the Pelton wheel experiment. Thank you.
Thank you from the previous presenter. My name is Muhammad Hazim Muhammad Razali and my metric number is MA18280. I will present about conclusion. As we can see, we accomplished our objective in the experiment, which is to design complete measurement technique for the fluid flow and to determine the amount of torque, the amount of power out, and also the efficiency of the Pelton turbine. As we can see, the result, the decrease the rotational per minute, or as known as RPM, of the turbine. So it will increase the amount of torque and also increase the amount of power up, and also increase the efficiency of the Pelton turbine. And also we can see that the power curve show the rotational per minute, which is RPM, is decreasing, and also the power up will also be increasing, but reach at the peak level when the power up is when the RPM is increasing, the power out will be decreasing after reach the peak state. We can conclude that the decreasing of the RPM of the turbine will affect to the increasing of the amount of torque, power out, and the efficiency, and showed in the result it will make more accuracy and precise. And also the power curve of the Pelton turbine have their peak state with certain rotational per minute, or as known as RPM, of the turbine. That's all for me. That's all for us. Thank you.